Okay, so today we are going to learn about module 1, which is about organic and inorganic compound. Okay, so in before we start any module, we are going to talk about learning objectives. So what are we going to learn in this module? Major differences between organic and inorganic compounds, and learning how are they different physically and chemically. And then the second thing that we're going to learn and spend a majority of the time today in the class and as you work through this next 2 weeks is on nomenclature and structural formula for organic compounds such as hydrocarbons, alcohols, aldehydes, ketones, all of those. And we will define something which is structural isomerism, and this is a concept we will need for module 2. So it's always nice to have a little bit of the next module in this one in a particular week. So when you go to that next concept, you're already getting familiar with what you need to start studying on. So these are our major goals. And I just want to reiterate that I would love for you to ask questions. So please do not hesitate. It can be chat, it can be raising hand, or it can be unmuting yourself. If you have a question in mind, and if you don't ask, I will not feel good about how I'm teaching, right? I want everyone to learn a lot, and that's what it is all about. I know it's about grades. Ultimately, it does come to grade. But if you do not have fun learning, then I think as a teacher, I lack somewhere. Okay, so we will try to work towards this common goal of making science fun and good for you. Okay, so whenever you come to this class, make sure you check your announcements and have a timetable. I know many of you are really busy. I saw that a lot of you have families, many of you are working in the introduction, and many of you have great hobbies. And this class really stumped me because almost everyone's hobby was binge watching and Netflix. It's like, so everyone has a common thing in here. So I just hope that you can identify some time, and it could be like every Monday, Wednesday night, or it could be Friday and Saturdays, and that's fine. That's how I do my work. I just want to remind you, I'm I work full time. Adjunct teaching is something I do off my work hours. So if I don't respond during the day, I'm not trying to ignore you. I just will respond in time. And if you are ever in a rush, put it in group me or text me. That's why I texted all of you so that you feel comfortable getting back to me. Group me is the best that way. So try to understand the topic well, ask questions, put comments and questions in discussion forum. That's another way. Then you should complete your quiz and weekly assignment in time. It's really important. And you are allied health majors. I mean, time is of essence. And then you should check your grade if you have any, if you have done your assignment, and let's say even if you have 19 out of 20, go back and check the comments. I would have written a comment in either the paper or on the side. I would have written, I think you don't understand this concept, contact me. So please make sure to do that. If you're scoring more than 80%, we are good. I mean, your goal should be 90% or more. But if you are not scoring that, then you should just tell me, you can just ask me a question like, what can I do to make my grade better? Simple. Okay. So let's come to this part, why studying biochemistry important. So biochemistry, as we know, is it's a combination of chemistry and biology. So it's more like how chemistry is applied to biology and biological processes. Okay. And when we are talking about allied health, it's of paramount importance. When you will go and pick up like a bottle and look at a label, it will talk about a compound. So essentially, it's going to be chemistry. So it's very important that you embrace that side of your future work. Okay. So some examples of biochemistry is like, of course, you need to know about the teeth and details. And then when we talk about cavities, it's not just simply a biological reaction, it's fermentation too. So it's a chemical reaction as well. And that's something that you need to learn about. and then how certain chemicals promote teeth whitening. All of these are good examples for you to learn. So one of the examples I thought I would share with you is because we are all, a lot of us like chewing gum. I myself use chewing gum if needed, as needed. So xylitol, it's a natural 5 carbon sugar from the birch tree, and you see the structure here. Okay, so bacteria cannot use this as a source of energy. So xylitol gum can prevent tooth decay because it helps in, of course, getting things which are stuck in the gum. And, it just acts as a natural cleanser. It helps in, of course, clearing up, but it also helps, chemistry wise, it helps in reducing um, acidity and making sure that the teeth is in a better health, right? So, so this is the reason we use. So you can see by this example that we have a little bit of biology, a little bit of chemistry, because if we didn't know that, why do bacteria not use it as an energy source? Or we can think for future, what are the other natural 5 carbon sugar sources which can be used as chewing gum and yet not be used by bacteria, right? So there is always that future component to science. So we're going to start with something simple. So I hope not to bore too many of you if you already know some of this stuff. So the first thing is we are going to start with the structure of an atom. So an atom has a nucleus in the middle, and it has protons and neutrons, which are marked by red and blue balls. And electrons are circling around in orbits. This is a very simplistic model. Okay, that's a very simplistic model. It's nice for learning, but it is too simplistic as well. Just to warn you, I guess, because we are going to see how it's not exactly like this in a couple more slides. So what we see here is 6 protons and 6 neutrons in the middle, and 6 electrons, which are circling around or orbiting around the nucleus. Okay. Now, about some of the things that we should learn about. Let me see. Is that the neutrons are neutrally charged. So throughout these lessons, I'll keep giving you tips on how I remember these things as a student, so that it might help you as well. So neutrons are neutral and they have a mass there in the middle. Protons, so P for proton, P for positive. So protons are positively charged and they have one mass unit and they are also in the middle. And electrons, which are negatively charged, they don't have too much mass. So, electron is negative and the rest of them, you can see P for proton and positive and N for neutral. Okay, these are things you probably already know. So, and also just a reminder about the periodic table, that the mass number is the one that is the higher one, which is comprised of protons and neutrons, and atomic number is the one that is the just the proton number, not electron, because electron number can change. Okay, especially while we are talking about bonds. So this is the representation. It's called atomic symbol, and this is how it is represented in the periodic table. Not all periodic tables look same, so we just have to be careful and understand these before we, you know, use a periodic table, of course. So these are the absolute masses, and this is the approximation. So it's not like electron has no mass, but if someone asks you, say it has a very, very less mass, and that is in atomic mass unit, which is itself a very small unit of measurement. If you have any questions, like I said, you can ask in the chat. Okay, so isotopes of hydrogen. So we are going to start with the most simple, or the first element, that is hydrogen. Hydrogen has these 3 different forms, which are the same number of protons, and that is why they are all called hydrogen isotopes. However, what is different in there is the neutrons. Okay, so hydrogen has no neutrons, deuterium has 1, and tritium has 2. So these are the so this is what makes them different. They all have same electrons. So now you can see the mass number has changed. It's just one for this, one and one, that's two for this, one, 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 that's three for this. So that's how hydrogen, deuterium, and tritium are different. But there is also another fundamental difference. And that what happens is tritium is radioactive, which means that having such a heavy nucleus makes this atom unstable. When it is unstable, you know, so imagine something, which is like have taken, have eaten too much. So they're going to, in some way throw up or do something. So that's exactly what happens here. This is like radioactive and it wants to, it's at a different energy state. And so it wants to emit something. So what it emits is either an alpha particle or a beta particle or gamma rays. And we are not going to be studying about these, but just for your information. Okay. So now we are going to look at three different definitions, of which we are going to use all of them. I think more of the molecules, I guess, or compounds a little more. So the first one is elements. So elements are made up of only one kind of atom. So it cannot be water, for example, only one kind. Okay, so that's why they say periodic table of elements, only one kind. Okay, but when we talk about molecule, it could be a combination of atoms like just hydrogen alone or hydrogen with water, with oxygen, I'm sorry, to make water. So this could be, these combinations are molecules. So it's even things that are in elements which are combined, that could be a molecule, and a combination that could be a molecule as well. What about compounds? Compounds are made up of different kinds of atoms. So they are not having this hydrogen in here. This just like all these, just a combination of hydrogen with oxygen or carbon with oxygen. So these three definitions can be confusing. If you have any questions or clarifications for me, you can ask them now. Now about the elements, you can see that examples here are of pure, of pure element, for pure atoms, and there is a combination of hydrogen and oxygen atoms. Okay. So let me move further. Okay. So the cells are the basic structure, and these cells are um, within these cells there are all these different compounds and molecules and elements. There's this makeup for this diverse size and shapes and all of these different functions of the cell, because all of the macromolecules, as we'll see in one of the next slides, are made up of these smaller molecules. So there are 92 naturally occurring elements, and so we're going to take a look at that. I think that there is some interesting learning checks in between. This is for you to do it on your own, and then see if you did not understand, then go back to the slides. Okay. So I just want to say that if you have any questions about learning check, or if you want any, if you want any clarifications or on any answers, you can ask me. I do think it's pretty simple though. Also, for any kind of assignment or exams, I just want to mention here, because this is the first learning check here, is that I do expect you to do everything with a lot of honesty so that you can learn well. Okay. So let's take a look at the periodic table. This periodic table is a little bit colored because we have bulk biological elements identified in yellow, the trace elements in green, and some of the rare, like really, it's not present in all organisms, but some essentially trace elements, like for some species, in this orange or red color. So that's what it is. And if you really look at the distribution, you will see that that human body, surprisingly enough, because of the amount of water it has, of course, has lots of hydrogen and oxygen. Even though, we clearly know that, carbon is the one that kind of gives that framework, but you can see that This is a majority, whereas in contrast, the Earth's crust is a little bit different. This just for your knowledge. Okay, so we looked at these atoms, hydrogen, carbon, oxygen, and nitrogen. And I'm sorry, what just happened? Okay, and then they make these molecules which are small, such as water we mentioned, nitrogen dioxide, carbon dioxide, all of these. And then these make up the macromolecules. Um, and then these are the ones that are making up the different parts of the cell. So I'm going to come to that question in the chat. So there is, I just want to say that we are going to have the next module will be on carbohydrates. That's module 2. Module 3 is on lipids. Module 4 on nucleic acids, and module 5 is on proteins. So just letting you know that you're going to be spending a lot of times understanding like how the chemistry behind many of these things and what is their biological role in the cell, and of course a lot of time in human body. So all of these contribute to these organelles or these different parts and of cells, and then that is what makes up the a chunk or a major a majority of the cell. Of course, there is lots of different parts in the cell, but we can attribute every single part of the cell to a certain macromolecule or a certain molecule. Okay, so now about the slides. So the slides are posted as a PDF to um, the module 1. So if I can take you there, but just letting you know it's on module 1. It's already posted, it's there. And this lecture will also be posted just as I'm teaching. So living things are made up of organic and inorganic molecules. So you can see that there is among the organic compounds is DNA and sugar and methane gas, I guess. And then there is in inorganic compounds, there's carbon dioxide, table salt, and diamond. So you probably might have noticed that organic compounds are the ones that are more like hydrocarbons and their derivatives. From your prior knowledge, it's probably something that you might notice that, okay, yeah, carbohydrates are organic, or DNA is, of course, organic. And table salt is not, because that's sodium chloride. Inorganic compounds do not contain carbon or hydrogen, and that is what distinguishes them, the organic compounds. Okay. So these are their properties. So if you look at, there are 2 pages with 2 tables in different formats, depending on what you like. Organic compounds are mostly covalent. Here is an example. In organic are ionic, some are covalent. Polarity wise, they are non-polar. So non-polar means they do not like water. Okay. Polar means that is water inorganic? No, water is polar. It's polar. So which means, oh, you mean that way? Yeah, you can. Yeah, you can say that. Yeah, definitely. It's inorganic, because it doesn't have carbon and hydrogen. So that cannot be organic. So of course it's inorganic. Yes. Good question. So now the melting point for these is pretty low. A lot of gases. So think about it: ethane, methane, ethanol. Wow, that evaporates. Like you put it on, your rubbing alcohol in the skin, it's like gone. So yeah, we know that melting and boiling point should be low where these are high. Flammability is high. Oh, we do know that alcohols catch fire. So I'm just giving you examples that will help you remember these, because you may be asked these questions in the exam, right? Solubility in water, not soluble. These are mostly soluble. Particles in solution, these are like, they just have molecules. These produce ions, of course, because they're ionic in nature. So a similar table is given here, and you can go through it. There is more examples on whether they conduct heat or electricity. And you can imagine if it's ion, it's going to conduct. Non-ionic stuff, it's not going to conduct. That's why it's poor conductor. So always nice to find, just the best way to study is nice to find some progressively, some logic. And if it's not making logic, get back to me or ask someone, right? Okay. So you can go through the learning check by yourself. And now we're going to start the main topic for this part, which is how do we name organic compounds? Okay, and I'm hoping that I'll try to make it as clear as possible, but it is a challenging topic. Okay, so I hope that everyone is staying very focused as we go through it. Okay. So there are different ways of expressing molecules. Like there is formula, there is molecular formula, there is structural formula, there is perspective drawing, there are models. There's so many different ways of doing this. Okay. So we know about this arrangement, right? But what I'm going to bring to your attention is that we talked about this, right? Um, okay, so I have a question here: is does inorganic compounds have to have both carbon and hydrogen present, or one or the other? Second one or the other. I will tell you carbon dioxide. I'll give you two examples. Carbon dioxide is inorganic. It does have carbon. It's not organic. I'm trying to think. Hydrogen. What could be the example? Hydrogen fluoride is a gas. Hydrogen chloride, inorganic. It dissociates really well. It makes ions. And that means that if it's just hydrogen or just carbon, it's going to be inorganic. But the presence of both is what will make it organic. Okay, again, great question. Very nice question. Helps everyone understand when you ask these questions. Okay, so I do want to say here that we would love for it to be like this, and that's what you have learned. But I do want to quickly correct you that that electrons do not really have orbits. Okay, they have orbitals. They move around in orbitals. They do not have like Earth orbit. Like there is orbit of Earth around the sun, and Earth moves in its orbit. Not really that. Okay. So the reality is they don't have sharp boundaries. And so these orbitals are a little bit different. So that's why we need to relearn a little bit more. So the orbitals are S, P, D, and F. And so if you have not seen this before, these are the four different orbitals arranged according to the energy level, which means that S would be the lowest and F would be the higher one. And of course, there is different levels, which we are going to talk about in next slide. Next to next, sorry. So there is suborbitals too. There is orbital and then there is suborbital. Just I want to tell you that there is a principle called Pauli's exclusion principle, which says that each orbital can hold only 2 electrons of opposite spin. And so each suborbital, we have to remember, holds only 2 electrons with opposite spin. So for now, bear with me till we get to 2 more slides, and then I think all of this can be put together. Okay. So we're not going to look at this diagram right now. We are just going to focus on this side. Okay. So let's look at this part where we talk about atomic orbitals. So S is 2, and 2 means it can hold up to 2 electrons. P is 6, which means it can hold up to 6 electrons. D is 10, which means it can hold up to 10. And F is 14, so 14 electrons. Now let us look at these parentheses. 6 electrons are going to go in 3 suborbitals. Why? Because we know that one suborbital can hold only 2 electrons, and they should always be opposite spins. So which means that every time we talk about one suborbital, we think of only 2 electrons. You are not going to be using these concepts, but you are going to, if you learn this, it will help you understand the nomenclature much better. That's all it is about. Okay. So now you see this mark, it says, do not worry about these yet. So we are not going to worry about, my mouse is acting completely crazy. So we are not going to worry about D and F. We only will talk about S and P in this module and in this entire class. Okay. So if we see here, there are these arrows. in this here red arrows, these are the ones that represent electrons. And we are going to use these arrows to represent electrons. Okay. So for example, we're just going to look at hydrogen. We love hydrogen because it has only one electron, so we can understand it really well. So a hydrogen, because we have to start with S, then go to P, then go to D, and then we go to F. And I promised you we're not going beyond P. So the first is S. One S, one is the first, that first orbital, and then one S1 represents the hydrogen's electronic configuration. How does that actually look like? So these are the uh, this is the orbital. You can see this is not a well-defined ring. This is where you would find hydrogen electron if you started looking for it. Imagine if you were very, 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 very tiny and looking for it in the hydrogen, inside the hydrogen atom, you would find it somewhere here. Okay. And similarly, if we go to other elements, if you talk about 2s, where would you would find it? And then 2p, and then 3s and 3p. So not going to worry about all of them. All you have to remember is, yes, they are in orbitals, not exactly in orbit. Orbit is okay as a simple concept. However, this is the reality, because electrons are particles and waves, right? So there is a different component to it, and we are not going to explore it in this class because it's not physics, but we are going to just learn a little more about it. So now we are getting back to our more comfortable zone where we look at this periodic table, and I have just written these down. Okay. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So now what we did was we just wrote down this number 1, 2, corresponding to each one of them. Also wrote down the electrons, whatever is the atomic number. If it didn't bond, which it didn't in this case, it's straight up from the periodic table, it's the same number of electrons. Okay. So I put a happy face for these, the helium and neon. Okay. Does anyone know why it has a happy face by any chance? Before we go to the next slide, because in that the answer is in the next slide. Why possibly did I put like helium and neon are happy? Okay,
They
good.
have 8 valence electron.
Say that again.
They have 8 valence electron.
That is a good response too. Yes, stability. Okay, yes, I think you guys are getting there. Very good, very good. Okay, so now we are going to find an answer. So we look at hydrogen. So we go one by one. 1s1, that's fine. Helium, 1s2. Remember, S can have only 2. Okay? It can have only 2. It has 2. Which means that what's going to happen with helium is, if anything tries to interact with helium, helium says, no, I'm happy. I don't need to interact with anyone. Okay? It does not want to give its electron. Its configuration is of S shell is complete. It's not going to react with anything. That is why it's called a noble element. Okay. So this lack of interaction makes helium, a noble element, and it's stable. Now, what happens in case of lithium? Lithium has 3, so 1, 2. So we have 1s2 is filled now, and 1 cannot make P, so we have to go to 2s. So like I said, I promise you, you only need to know 1s, 2s, and 2p. Okay. Then we have 3s. We're not going to go there. So 1s has 2 electrons, 2s has 1. And this 2p has 2px, 2py, 2pz. We are not going to write that down. Just leave this blank. So lithium thinks, like, how can lithium be like helium? So lithium wants to be like helium. So lithium thinks if it can give away this electron, then it will become just like helium. So everyone is trying to get their shells complete. That's what this whole big deal is about in chemistry. Similarly, beryllium has 1s2, 2s2. Boron has 1s2, 2s2. Now 2s2 is full, so we must go the 2p. So that's one electron. And like I said, arrows are electrons. Carbon has 1s2, 2s2, and then 2p2. Nitrogen has so many. Now I'm going to jump and look at fluorine. So the fluorine is 1s2, 2s2, 2p5. Wow, that is so close to neon. So what does fluorine want? So fluorine thinks that if it could get just one more electron, just one more, then it would look like neon. Okay. So that is why hydrogen fluoride is such an explosive kind of actually it's acid, but it's very volatile, and it's very reactive. So the fluorine is desperate to get one more electron, and it can pair up with hydrogen, it can pair up with lithium, it can pair up with different things, of course, to get that. But in nutshell, its goal is to be like lithium, which has everything full. So when anything tries to react with neon, neon says, no, I don't want to interact with you guys. I have all my electrons. I don't care about anyone. Okay. So you in nutshell, you fill 1s first, then you fill 2s, then you fill 2p. But the goal of each of these elements is to fill up their electronic configurations completely. Okay. So now the question is about carbon. So the question is, how many electrons does it need to make it full, have all the electrons in the shell?
The
Four.
carbon needs 4.
Four. Okay, good. Everyone said the same thing. So looks like we are going along together. That's good. Yes, it's need four. Now you have to remember that, because you know why? Carbon is our favorite element in this class. Like, I know this feels like so biased that we only like carbon, but we do like carbon a little more. Okay. And we're going to study that a little more. So why do atoms form bonds? So they try to be getting these bonds so that they can complete that noble element configuration. So for example, hydrogen. Hydrogen has one. It tells to another hydrogen, hey, let's form a hydrogen bond together. If we form this bond together, then we both will have two electrons, and then we do not need to do pair up with anyone else. And it says Lewis diagram, because Lewis diagram has a electron shown here. If it's electrons shown here, that's Lewis diagram. So this hydrogen and hydrogen come together, and now they're like, hey, we kind of look like helium. We are noble. Okay. So they're all trying to do that, complete their shells. And how it happens is that, each shell will hold electrons, and, that's what will form the bond. Okay. Okay, and the filled shells are very stable. That's always what it is. So now let us focus our attention to carbon alone. So carbon needs 4 electrons to fill the shells. We know that. So carbon does a little trick. So carbon invites 4 hydrogens and says, hey, I know that I'm going to make this red. So I know that, so each of the, oops, let me make this opaque. So there are 4 hydrogens, which are shown by red. Okay. Each has only 1 electron. And you may tell me that, hey, carbon has so many. Why did you show only 4 electrons here? So I'm just showing to you this one, this one, this one, and this one. This 1s2, it's not going to change. We're only looking at the outer shell, which is the second shell. If there were third shell, we will only look at the third shell. So we don't look at the inner shells. For a minute, let's look here. So this is 1s2, 2s2, 2p4, 2p2. They actually make, even though you don't need to remember this, but they actually make a hybridized orbital in which this guy, let me draw this for you. This guy says, hey, you can take this and put this over here. Okay. So that each one of us will need only 1 electron. They're just being nice to each other. So it gives it 1. So that is why there is sp3 hybridized. That is the sp3 hybridized orbital. Okay. So now we only worry about the outer 4 electrons, which are in black, and hydrogen ones are in red. So what has happened is hydrogen says, hey, I don't mind that because I have now 2. This hydrogen says, yeah, Pool with me, I have two, I have two, and I have two. And the carbon says, I like this because now I have all the ones that I need. So with all the reds filled, carbon has successfully completed its shell. And that is why, you know, this, if you recognize, is the methane gas. And that is why this is a popularly, available, found, um, you know, compound in nature. If you want to write this as a bond, this would be the structural formula. If you were to connect these and say, like, you know what, I'm going to connect this with this with this with this, and this with this, then these are the four bonds. Okay. Um, so that's how this four bonds are represented. Please note that this is the electron dot diagram and this is the structural formula. And in reality, this is how it looks. So why am I showing you something in reality? Because I don't want you to think everything is flat and on paper. Not at all. Most of the things that you see are in 3 dimension. So just getting you used to of that, this is a 3 dimensional molecule. Okay. I think I'm going to pause here and ask you if you have any questions about this slide. Okay, no questions, no problem. I'm going to clear this. Okay. So what we have learned in this slide is something important. So let's just recap in one sentence what we have learned. What we have learned is carbon needed 4 electrons. So it formed a covalent bond with 4 hydrogens. And now electronic configuration of hydrogen and carbon is like they have completed that those configurations or shells. And that is why there is CH4. It is a compound, and that's how it is formed. Okay, so now we are going to think of carbon as or always wanting to have 4 bonds. Okay, so this is just a cartoon, but the idea here is that it should always have 4 bonds. Does not matter hydrogen. It could be oxygen. It could be chlorine. It could be anything. However, it needs to bond with 4 things. A carbon, just it's naturally all of these elements are meant to complete their configurations, and that is the reason why they would always react. Okay, so this is going to be the basis of understanding the nomenclature. For example, let's start with something which is a little bit different. So we were looking at 1 carbon, now we're looking at 2 carbons. Okay, so I want you to be able to see here that these 2 carbons, they have come together and formed one bond. Okay, and then now I'm going to draw that in red so you can maybe a little bit thick. So this is the one bond that they have. So I'm just looking from the perspective of this carbon. I'm not thinking about the other carbon right now. So what has happened is that this carbon has one bond. So it needs 3 more. So 1, 2, 3, and that makes it 4. And that is why we put mark the rest of them with hydrogen. Similarly for this carbon. And we will learn in the next 2, 3 slides, coming slides, we're going to learn why this is called ethane. But this two carbon compounds starts with eth, and this is an alkane, so it's an ethane. The second one is ethene, and it is possible for carbon to form double bonds. And so that's what has happened here. It is forming a double bond with this carbon. Okay, and then this one after that it has two fulfilled, so it can need only 2 more. And similarly, this needs only 2 more. So I'm just writing it in the structural formula way, but you can see the electrons are shown here too. Similarly with ethyne, what you have here is there are 3 bonds. 1, 2, 3. So all it needs is 1 more of each to make it a full configuration. So this ethane, ethene, and ethine with single, double, and triple bond are still able to maintain their full, whatever, 4 bonds maximum possible. And at each stage, hydrogen also has one more electron, so that makes it 2. Okay, I hope that this was okay. I'm going to give you some more examples, okay, as we go. But this sets us the proper background to do the nomenclature for many of these things, which you will be using in your job. You're going to be working with, at least with alcohols. For many of the medications, might be different derivatives. There can be ketones, there can be when one of the example in assignments, you will see that it asks about that. There can be esters, there can be amines, there can be so many different things. When you pick up that medication and you're giving it to the patient or you're using it, you will see that many of these will come up. So what is a good way of naming them? Something that is not confusing, something that doesn't seem too difficult. So that is what this slide is all about. Okay. So just like in English, we have this method of like, um, having words split in prefix and then suffix. Just like that, we have put the nomenclature, split it in 3 different, parts. And so the first step is to name the prefix. So prefix of a parent molecule is based on the number of carbons. If there is 1 carbon, that's a specific name. If it's 2 carbon, a specific name. So you start with the number of carbons. Okay. Then after that, you talk about if there are double or triple bonds between carbons, not between carbon and oxygen, between carbons. Okay. And then the last one, so the double, triple bond or the single bond would decide this ane, ene, or ine. And finally, you have the primary functional group, which would be the alcohol or the ketone or the ester or whatever that is, suffix is. That is the suffix. So let's take an example because this may seem like a lot of jargon. So this is the example here. I think it's not hard to say that this is, that should be alcohol. That's wrong. That's not right. Let me just write it here. I mean, I can update it. Alcohol, because the structure is alcohol. So this is a 3 carbon something. We know this is 3 carbon. And the name for 3 carbon is prop. So we put that here. Is there any double bond between these carbons? No. Is there any triple bond? No. There is only single bond. So N. And what is the functional group? Is there something special in here? Yes, there is something special. What is that? OH. OH is all. That is the hydroxy group or the alcohol. That's called propanol. Okay, so that is why you combine the prop with the and the all, and you get propanol. That is what we are going to do for naming, and I'll make it interactive. I'll ask you questions, and you can feel free to ask me back if something is not clear there. Any questions about nomenclature so far? Is this something that you guys have done before? How many of you have done this before? Some of you have done, some of you, many of you have not done. Okay. Yeah, okay. So no worries. You will, this class is enough for you to learn. Okay. So now we are going to look at this. Okay. So the first one to learn is prefix. So let's look at this. If there is 1 carbon, it's meth. If it's 2 carbon, it's eth. So just let me highlight that for you. 3 carbon is prop, 4 is bute, and then 5 is pent, 6 is hex, 7 is hept, and 8 is oct, and so on and so forth. You can also write it in different way. This is another way of writing. And you will get with condensed structure formula. Sometimes, it just takes a little bit time to get used to. But you can see there are 3 carbons. And middle one has 2 hydrogens just because it's needs only 2 bonds. It's bonding with carbon. So this is what it is. And I personally have a feeling that it's much easier to remember this part, just because like we know pentagon, hexagon, heptagon, octagon, and nonagon and decagon. So it's kind of easy to remember. I would think like the more tricky is this part. So for this, meth 1, eth 2, prop 3, and but 4, it would be nice if you remember, if you can print it out and keep it near your study area, or refer back to it again. That would be that would help you memorize this. Also, you can make up some stuff. I think for last time what I did was uh, I made up this little thing for students, and I was like, that was mom eats um, popcorn. No, mom eat pancakes, bread. Okay, so that was like mom eats pancakes and bread, and you can make anything else, or you can just make popcorn and butter, and that's fine. But if you go sequentially, mom is one, to meth, eth, prop, but. If you cannot remember the sequence, but you remember the names, that would be a good one. But you have to somehow make an effort to remember this. It would be extremely useful. Okay, so that said, we can now move to the next step, and that would be single, double, or triple bond. So when there is single bond, it's ane. Okay, when it is double bond, it's ene, and triple bond is ion. So AEY, that's what it is. Okay. So this is actually, this is hydrocarbon. Hydrocarbons are the compound containing hydrogens and carbon. And we're going to learn more about that. So there are 4 different types of hydrocarbons. And so what is shown here is alkane, alkene, alkyne, and aromatic compounds. So that's what it is. So that's the middle. So now let's come to the end. And for the end, what we have is suffix. So we're just going to focus on this for once, the pink parts for one. If it is single bond, ane, no other functional group. It should have nothing else. Double bond is ene, triple bond is ion. And if it is OH, it is all. CHO is al. And you may be wondering, how will I remember this? Don't worry. You will remember this. This is really a matter of time. Okay. The more we practice. COH is oic acid. This is OH. There is ethers and amines and amides. So these are all these different back, or the suffix. And sometimes we use OH as a prefix, and that is that when that happens, we call it hydroxy, but it wouldn't be like right away. Maybe, probably have some questions later. Okay, so okay, let me, it's been 3:40, started 2:30. Thank you for hanging on, guys. I'll have to say that because it's been, you've been really patient. Okay, so we are now entering the part where we will start naming things. Please note that here, every time the definition is on the right side. I welcome any suggestions that you have for notes for me, because I made them. And if there are anything that you find wrong, you should immediately tell me, like, just tell me directly. In science, only the science is right. It's not about you or me. You can just point out if there is any anomalies. Okay. So methane has, this is the structure methane has. We are now familiar with a little bit. So we know meth is 1 carbon. And if it's an alkane, then it's going to be like this. This is ethane, it's 2 carbon. And this is propane, that's 3 carbon. Okay. Now let me go to the next one. And I think we should be done with the majority of this nomenclature in about 15 minutes. So in case of alkenes, we have a double bond between the 2 carbons. Okay, so ethene and propene are good examples. If you see here, eth is 2, prop is 3, in is the middle, and since there is nothing else, we can comfortably put a E in the end. Now look at this butene structure. Sometimes the double bond can be in the beginning, then it is called 1-butene. Sometimes the double bond can be at the second position, that can be called 2-butene. So those are 2 different forms of butene, which is not possible in some of the other ones. Yeah, not possible in the other ones. Okay, so now let's look at the next one, that is the alkyne, which has triple bonds. And then um, this is the structure that you are looking at for propyne, which is 3 carbons, and butane is 4 carbon. Okay. So now we come to something with functional groups. So what we have done is, if I remind you, the first 3 are the hydrocarbons. Now the rest of it is hydrocarbon derivatives. So something for you to remember, these are the derivatives. This is not the hydrocarbon itself, because it has O and it has N and all of those. Okay. Okay, so we are looking at alcohol. So if you look at the definition here, alcohols are organic molecules assembled from carbon, oxygen, and hydrogen atoms. If you see here, this is the C, that's 1 carbon attached to 3 hydrogens, but the 4th hydrogen is replaced by a functional group OH, and that is why it is meth plus ane plus all, methanol. Similarly, in case of ethane, 2 carbon, so eth, single bond, ane, and all, ethanol. So what I want you to do is, I want you to name this. Can you write the name in chat, or you can unmute yourself, or whatever that is? But what would be the name of this compound?
Propanol.
Propanol. Okay. Anyone else? Any answers? Anyone else has a different response, or? No one has else agrees or disagrees with it? How is that possible? Any other response on, like, is it propanol or not? Or if it's something else, then you should say that. Okay, well, since no one else answered, yes, propanol is the right answer. But let me make this a little bit more interesting for you. Okay. Yes. So I'm going to ask you to draw the structure of butanol. I know most of you may not have a paper or pen handy. Take your time. You're going to draw the structure of butanol. I'm also going to draw, not just you, and I'm going to show you, in the, hopefully I can show you in the camera. But yeah, go ahead, draw the structure of butanol. And for that 1 second, maybe if you can just turn on your camera and show me, don't be shy. I'm also going to draw here. I just want you to start doing this hand drawings, because it's one of the important parts. And if we were in person, that's what we would do. So let us see who can draw this first, or who can just draw it. It doesn't have to be first or second. I mean, like, who would take the initiative and draw it. By the way, that's how your oral exam is going to look like. I ask you to draw something and show. Let's see. Actually, that is, let me see. That is correct. Yes, absolutely correct. Yes. Oh, I'm sorry. I accident. Did I? Yeah. Is that? I hope I didn't press something funny. Yeah. So if anyone else can show what they draw. Did yeah. Okay. CH2. That was an interesting way of drawing CH2. One of your CH could be CH3. Yes. Now it is perfect. Now it is perfect. I like that you draw the ball and stick structure. That's good. Okay. That's good. So I think people are getting it. Anyone else was able to draw it? The more we draw, the better we get at this. I do also want to say that I'm going to draw alternate structure of propanol, and that would be like this: 1, 2, 3. Okay. And feel free to yell if you don't like the structure. When you are doing a skeletal structure, this is how the propanol would look like. Wait a minute. Yeah. Yes. So this is each of the ends represent a carbon, and then the OH is in the end. So it does look very different, and this is what something it looks like. Okay, so let me clear this, and if you didn't draw, then maybe you should draw it at home later. Okay, I did something funny. Okay, so let me just go to the next one, and that is aldehydes. So aldehydes have a C double bond O group, but aldehydes, they are having, because they are in the end, it's essentially a CHO group because they are in the end. Okay, so they are ending with a suffix of AL, so it will become ANAL because it has no double bonds. So look at this one, that is methane with a CHO. It's a single, basically C, even carrying the functional group. So that is why we call it methanol. And I'm going to just divide it in three parts just for you to understand. That will be meth with a single bond and L, methanol. So can you name this for me? Look carefully how many carbons it has, and the rest of the pattern should just follow. So as many of you can answer, you can put it in the chat real quick or just say it. I won't say the answer till some people have responded. So go ahead and use your favorite way to respond. So what is this compound? CH3CHO. Does anyone know? No one knows? That's going to be crazy. Okay, I see some people responded. Okay, ethanol. Yeah, that's correct. So it is ethanol because it is ethane with eth with the N and al. Okay. So now let's look at this, and that will be ketone. So one thing I want to tell you about how to always remember about aldehyde is it's always wants to be at the end. Always. It's never in the middle, always at the end. Okay. You will see the contrast in ketone, which is always in the middle. C double bond O and always in the middle. And that is why it doesn't have H because it's attached to C. So what is the name for ketone? It's one, just like ketone. It's kind of easy to remember. So look at this one. This has 4 carbons. So bute and on, butenon. Okay. So butenon. And now we have another one here. So let's try naming this. So what we need to always do is go back to that chart, find the prefix. It's a 5 carbon. What is the prefix for 5 carbon? Okay, we find that it's a single bond, and then the functional group is on. So we put all of that information together, and then help me name this one. You will really thank yourself when you do this because the assignments will appear so much easy. Okay, let's see one response. Anyone else? If you don't understand, you can also tell that, no, this is like completely unclear. You can tell me, you lost me. I'm not sure what was going on in the class. Okay. Okay. Propanon is the right answer to this one. So yeah, I mean, sorry, not propanon. No, hold on. No, my dear. There is 1, 2, 3, 4, 5. So, oh, that was close. That was close. Anyone else? We haven't reached the perfectly good answer. You still have time to say something. Oh, okay, Gina, my friend, you should have just interrupted me right there and then. But actually, can I tell you something for, um, um, you know, sorry, yeah, Pentanon. Okay. Yeah, so let me just tell you something really interesting about nomenclature. Um, you don't need to know everything to know the nomenclature. Okay, let me just pause for a second completely. Okay, let me go back. This particular topic, when it starts here, is the one you're going to use most. So whatever I said before this was in preparation for this. Okay, and it is totally understandable that a lot is covered in the first module. Okay, I can also tell you something which you will really love to hear. The first module actually is one of the harder ones. It only gets easier. So if you do the first module well, the next is going to get better and better and better. Okay, so that's our good news. Okay, for definitely, you know, so yeah, that's definitely something to remember. And if you ever feel like you're not exactly catching this, guess who is going to help you? Julie is going to help you, and Simone can help you, and of course I'm there to help you. So if you have any questions, so after this I'll just put on group me like, hey, if you didn't understand this, like send me an individual message and I'm going to we can set up some times. I think Julie said that she's available on Thursday from 7 to 8, but I can confirm that time with you guys and with her, of course. So you have to just remember this prefix, middle, and suffix, and you should be fine. You know, when you were learning these big words, when you were, let's say in fourth or fifth grade, it was like non-stoppable or unconquerable. They seem like so big, but then you realized un is the prefix, conquer is in the middle, able is the suffix. So it's almost like that, just in a totally different language, and so it looks fancy. Nothing fancy about it. As long as you can remember the prefix, or you can have the table handy with you, and then this is the middle and that's the suffix, you will be able to do it. And you can actually follow it from the very next slide I'm doing. You don't need to. Sometimes you feel like if you didn't understand until slide 17, slide 18 is obviously a no-no. No, not at all. Not at all. Don't think like that. Okay. So let's give this a fresh start. Okay. So now let me write down the step. Step one, how many carbons? So let me write the answer to that. That is 2. Then 2, single bond. I don't see a double bond between carbon and carbon. I see a double bond between carbon and oxygen, but that's not what I am looking for. Okay, so this has to be in. And then the last one is the functional group. And that's going to be COOH. And so that ends as a oic acid. So now I put this information together, and yeah, I see someone already answered something. Yeah, you can feel free to write responses. So this is for eth. I'm going to do it in different colors. So you'll feel like it's so single bond, that is for in. And then, where's the green thing? Okay. And then we have the COOH group, and that is the oic acid. So you see, we can also learn to say big words just because we know all the rules. Ethanoic acid, ethanoic acid. So now when you look at this, I'm going to give you enough hints, okay? Try to make this easy. 3 carbons. Remind yourself what is 3 carbon. And if you don't remember, no worries. We're going to go back to the table. What is this bond? Oh, I see this is single. I see this is single, so this got to be single. So and And then what is my functional group? I know I'm on the acid page, so it's got to be this acid. Okay. So if I identified the three things, and now because I don't remember what is the 3-carbon thing called, I'm quickly going to run back to that page. Excuse that, all the geometric figures. I'll be like, oh, I know 3 is prop. Okay, I got that answer. Now I can go back quickly. Okay, 3 is prop, 3 is prop. I'm going to remember it. Okay. Now we have prop. So prop, and then you can do the name. Yes, that's correct. Some of you wrote prop, and then you were very, very close. Well, someone was really, really close. Prop n, and then remember the functional group. The functional group is going to be so mad at if you do not include it. Put all the effort in, and you don't even care about it. We need to care about it. Okay. So we are going to just put here. I'm going to write it separate. Prop with an n and an oic. I'm sorry. Okay, so now I can put this together. Propanoic acid. I got this. Okay, so that's how I'm going to do it. Oh, good question. Very nice question. Is it, am I saying your name right? Imebete? Can you say your name, please? Emebet. I'm so sorry. Yeah. If it's any consolation, people like mess up my last name a lot.
Oh no.
Embet. Embet. Okay. So great question. What is an R group? R group is the functional group. Okay. So R is same as the functional group. So which means, let me clear this up. So great question. I love this. So you can see this is the R. This is the functional group is C double bond. Oh, so I'm sorry. Did I say R group? No, it's the side chain, not the functional group, the side chain, this part. Okay. So whenever we are calling this R, that's the side chain, all the carbon stuff, which is not the functional group. Sorry, not the functional group is the R chain. Okay. So for example, it could be CH3, it could be CH2, CH3, CH2, or it could be anything. So what is an R group? Let me make this here. This is an R group. This is an R group because, you know, methanol is a little bit like small, so it doesn't really have an R group, I guess. But it's very good question. You know why? Because it will keep coming up in all the modules. So let me show one more time. R group. R group is right here, not the functional group, not the functional group, not the functional group.
Okay, so that makes sense. So we need to memorize all the like R groups.
You need to, but like I said, there is a trick to it. You know, I mean, I wouldn't really say memorize it. Like I'll show you how, if I have to do it, like how I would do it. So suppose, let me find a blank space. Oh, this is enough blank space. So this is how I do it. So give me anything to make. Like, okay, this is like a give me your wish molecule challenge. So whoever gives it first is the one that I'll make, because I can't make everything. And I can assure you that any one of you would be able to do that. So give me any random molecule, which is like 3-4 carbon with an acid or something. It doesn't have to be an aldehyde. Oh, okay, that's nice. Random side chain because it starts with R. Yeah, that's a great way. Thank you. Thank you so much, Esel. Okay, so you guys, are you giving me something? Or if I give to myself, I'll make myself do less work. You can make me do more work.
Ammonium, I think.
Good one, my friend, but that is an inorganic compound, right? Okay, so let me do something which looks like a big name. Okay, I'm going to do, someone give me something. Heptanoic acid. Oh, thank you. That's perfect. Heptanoic acid. So I need some help from not Yesel, because that would be unfair, because she's the one who asked me to do something and then I'm asking her. So someone else can tell me hept means how many carbons should I make? I'm wondering, how many should I make?
7.
7, great, okay. So I'm gonna make 7. Okay, I'm trying to find a place to do this. This is space. I don't want to, this heptanoic acid, right? So acid should be here. Okay, I can make it here. So since heptanoic acid, okay, so 7, 1, oops, 2, 3, 4, 5, 6, 7, done. Since it's an acid, so last C should be OOH. Okay. So I covered the hept part. There is no double bond, heptane, oic acid, that's fine. What is missing in this? Something is missing. What's missing is all the H. So I'm like, now I'm going to go through each carbon. I'm going to assess this one. How many does this have? Oh, this is only one bond, so it needs 3 because everything should be 4. This has 2. So how many should I put? Just 2. This is again 2, so this should also be 2. This has 2, so again, this should be 2. So like that, I'm going to take care of each carbon individually. That's, by the way, an assignment question, your assignment question, okay? So you need to be able to do this. Then I'm going to, just for my convenience sake, I'll say star is hydrogen, okay? It's not star, it's hydrogen, okay? It's easy to draw. So now I have the structure of heptanoic acid, which is 7 carbons with the acid group and all the H's in place. And if I'm trying to write it down in different ways, I could write it C7. How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait a minute. 6, 7, 8, 9, 10, 11, 12, 13. And then you have to count this also, 14. So it is C7, H14, and there are 2 O's, so O2. That is the formula. And that's the heptanoic acid, okay? So that's the kind of things you will be doing in assignment. Like, that's why I'm asking you these questions, because if you don't understand, you just tell me like, I don't get this, but this is how you do it. Let us say you need to draw something. You just put the number of carbons in place, and you put the functional group in place, then you fill it up with hydrogen. That's what you do. That's all you need to do. Okay, so more stuff. We're almost coming to the end, hopefully in a couple more minutes. And that would be one of these things is esters. Esters are like acid, but you see acids like to stay in the end, just like, aldehydes like to stay in the end, but esters stay in the middle. Okay. And they have a different name. You see, what happened is in between this carbon chain and O came. So, since an O came, this cannot be counted as prop, because prop is like 3 carbons continuously together, and these carbons are interrupted. So this is methyl, and then with after that is ethanoate. So methyl is the first part, which is actually in this case, it's a little bit differently named. It's like a prefix kind of thing, and then ethanoate. So oit is the name. Okay, so this is a little bit tricky, but I wouldn't worry about everything so much. It's not about worry. It's about how you do it. Now let us look at this one. This one is a ether, and that's what also is interrupted by oxygen. So I'm showing you 2 things which are interrupted. There are 2 ethyl groups and an oxygen in between. Now you may argue, why are you not calling it bute? Because butane is very particular. When butane is happening, it should be 4 continuous carbons. If you interrupt it with anything, butane is like, I'm not butane. These guys are separate, those guys are separate. I don't care about these guys, okay? So this is ethyl, and this is ethyl. And so that becomes diethyl ether. And so these are, again, just different ways of showing. When you are showing like this, you are just doing the skeletal structure, which is the carbons become dots. So carbons become like just like 2 dots in here, and hydrogens disappear. And that's the ball and stick, where carbons are black, hydrogens are gray, and oxygen is always red. Only 2 more left, and we are done. So the next one is methylamine. Okay, methylamine. So again, here you have methyl is the R group, and amine, NH2, is the functional group. So how do we, so this is also named a little bit differently. It's always amine, and it's not methane amine. I think you can call it methylamine. or ethylamine, and it should be fine. So these are just the same things. It's 1 carbon with a functional group, 2 carbon with a functional group, and 3 carbon with a functional group. And then the last one for today, and with a challenge question. So that would be ethanamide. So, sometimes when we are looking at these functional groups, we're like, wow, that looks so confusing. But, if you can just put it in one box and say, okay, that's a functional group. That's what it is. Okay, so just separate this out and then separate out the R group and then name it. It will not be that crazy. For example, CH3 with a C, sorry, this is, it's like that. But when you're counting the number of carbons, then you have to count this and this together, right? So that would be eth, no double bond between these two or triple bond, so N. And what is this green thing? That is the amide. And so that is what is this one, ethanamide. So here you look at this. I saw this really interesting molecule as 1, 2, 3, 4, 5, 6 carbon. So it is 6 carbons. We have to remember to account for this thing. Now, like I said, in geometry, what I do, when I see hex, I'm like, hexagon, right? So I'm giving you enough hint. So it has to be starting with, yeah, so hex and then hex, amide, hexanamide. That's correct. That's correct. Hexanamide, yes. Perfect, guys. Very nice. Good job. Okay, so we're getting this. Yes, my friend. That's right. That's right. So all of you are getting this. Some of you are getting this. I'll stay back after the class, and you can ask me like specific questions. So I have this fun little exercise for you, and I feel like when you encounter something difficult, like this is, let us say this is a difficult concept for you. I think the best way is to get to the root of it, learn it, and embrace it fully. I'll give you an example, and you may say like, oh, it's very easy for you to say because you did like a PhD, or uh, you did all that. But I will tell you, like, I'll give you an examples from my real life, like right now, so that you can see that I do jump on things. So there is this programming language called R. Okay, it's literally R, like R as in rabbit. Okay, it's very popular. Okay, a lot of people who do statistics, bioinformatics, they learn it. Okay, so I always wanted to learn it, but it's like so confusing. So what I did, I was like, I'm going to just sign up for a class. And I actually signed up for a class. Like yesterday, I kept contemplating. I was like, I'm going to sign up for the class and learn it completely, so that once I learn it, I know it's going to be a difficult journey, but I'm going to do this and do this right. Okay. So yes, I don't need to learn it. No one is telling me to learn R. Nothing is going to happen if I don't learn. But I'm like, I'm not going to be afraid of this. This is a new thing. I'm going to learn it. I'm going to use it somewhere. So that's what I encourage you to do. Explore, learn, get to the root of things. Everything will seem so much easier. Okay, last thing for today, and a little consolation. Classes are going to be way smaller than this, time-wise. This is just longer just because it's an introductory class, and module 1 is always takes time. Okay, so I'm hoping that every time we meet, the class probably is going to be more like 1 hour 15 minutes to 1 hour 30 minutes at the max. Okay, and then I'll just stay on for a little bit if needed. But we'll start at 2:30, be done like 3:45, 4-ish. We should be done. Okay. So now the last thing for today is isomers, and we talked about isotopes. So by now you should have realized iso means something similar. So isomers in this case are structural isomers, are things uh, which have same structural formula. However, they actually look same formula, chemical formula, but they look different. So for the sake of understanding this, I'm going to just write down the condensed formula. That is C3, three C's, 1, 2, 3, 4, 5, 6, 7, 8, 8H. So I'm going to write down C3H8 and 1O. Okay. So now I did that. Let me do this one. 1, 2, 3. That is C3. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Ah, that's 8 too. Okay. I'm not surprised because I already knew it, but I'm just saying both have the exact same chemical formula. They're completely different. One is propanol, which we learned, and one is methyl ethyl ether. So that is methyl, the meth group, and the eth group, and the ether is for the O. So that is, they are different. So these are structural isomers. They're like looking like some similar formula wise, but they are not same. Similarly, there are stereoisomers. So stereoisomers are, they're just structurally different. There can be geometric isomers where the things are on the same side, or they're, that's cis. So cis is for same. So let me write that down. That's how I remembered. Like whenever people say cis, I'm like cis is same, cis is same. That's how I remember. And trans is opposite. Okay, so cis is same, trans is opposite. So that's why functional groups are on the opposite side. It could be chlorines and it could be something else. Optical isomers, we're going to learn more of this. So I'm not going to emphasize too much, just for you to know that an example of optical isomers is your hand. So touch your thumb with the thumb and your all the fingers with each other. So face them and touch them. And it's like a mirror image of each other. Your hand is a mirror image of one hand is a mirror, palm is a mirror image of the other. And you'll be like, that's not a surprise. I knew this all day long. Now, put them um, put them one on top of the other. Okay. So now these are two hands. Now you put them on top of the other. You can see the thumb is sticking out. So that is what is, they are optical isomers. So they look identical as a mirror image, but when you place them on top of each other, you can see they are not actually identical. Okay. So that is optical isomers. So more of this later. Also, for just for you to appreciate that these are all three-dimensional structure, I just want you to know that very few things in chemistry are on paper. I know we're reading on paper and everything is online, but just for you to know. And that's why a lot of ball and stick models were included. So this is just sharing with you just a little bit detail on constitutional isomers and geometric and optical isomers, but essentially the concept is same. Cis is on the same side, trans on the opposite side. And optical are like I said, your hand, like which is mirror image of each other, but put on top of each other and they don't match. And that's the end of this particular module. There is some more information on stuff you would use in dentistry in future. I mean, it's nice to know that there are things which are related to things you're learning for from a future perspective. Okay. Stop sharing. Okay. Are there any questions that you have for now? If you feel like you want to stay back and ask questions, that is fine with me. And please do start working on module 1. So we will always, before the 2 weeks begin, we'll finish the module and try to give you that head start. That's about it. You need to make sure that you're doing stuff on time. If you need help, just yell for help.